Hi friend, welcome all to my educational channel Math A to Z. Today's discussion is on Dihedral Group, or it is also called group of symmetries of regular n-bond. This group is denoted by Dn and it contains 2n elements. So the order of the group Dn is 2n. Here regular n-bond means it may be a equilateral triangle, maybe a square, maybe a regular hexagon, pentagon, or regular n-bond, any one. Here we take a regular 4-bond, that is, we take a square and discuss all the cases or all the elements of the group. We make different movement on a square such that the square becomes in symmetric position finally. We see that there are only 8 different final positions for the corner of the square. Now we take a square with 4 different color corners, which are colors are blue, white, pink and green. We make a rotation of 0 degree. Rotation 0 degree. That is no change in position. This is denoted by R0. This is the first movement. And this movement, the square PW or PGBW becomes the same because no change in position, and this element is denoted by R0. This is the first element. Now into R90, that is the rotation of 90 degree. Rotation of 90 degree in counterclockwise, that is anti-clockwise. So PWBG becomes, since 90 degree rotation, so it becomes WBGP. In the third R180, that is the rotation of 180 degree, and it PWBG becomes BGPW, and this is denoted by R80. And in the fourth R270, that is the rotation of 270 degree, and the rotation of 270 degree, the square PWBG becomes GPWB. These 4 are rotation. Another 4, that is in 5 H, flip about the horizontal axis. PWGB, this is the horizontal axis. This is the horizontal axis, and if we flip the square about the horizontal axis, then it becomes GBPW, and this is H. This is named as H. In number 6, V, that is the flip about the vertical axis, which is PWBG, and the rotation V gives WPBG. And in the 7, D, flip about the main diagonal, which is PWBG. This is the main diagonal or principal diagonal, and this is D, and this is becomes PB. These are the same, but these are alternate, W and G. And the last, that is the eighth, is D dash. Flip about the other diagonal, that is off diagonal. PWGB. This is the off diagonal, and we rotate the square about the off diagonal. And D dash, this becomes PB. These are alternate, but G and W are same. These 8 positions are only 8 different positions of the square, and these 8 positions of the square are the element of this group. This is R0, this is R90, this is R80, 180, this is R270, this is H, this is B, this is D, and this is W. Now we make 2 operations or 2 movement together. We first take R90, then H. That is the rotation of 90 degree followed by flip about the horizontal horizontal line. And rotation of 90 degree gives PWGB, gives WBPG, and then H gives PGWD. And we clearly see that this becomes the D. That is, since D is PGWB, so we can write H R90. This is equal to D. This is the composition. So by similar manner, we make a composition table on the set of 8 elements, and the composition is as this, the composition of movement. Okay, now we make the composition table. Here 8 different positions of the square is given by R0, R90, R180, R270, H, V, D and D dash. And this set is denoted by D4, and it contains 8 elements. Now we make a composition table on this set together with the binary composition that are the composition of movement. Okay, and we fill up the composition table. This is the complete composition table on the set D4. Now, from the composition table, we say that this set is closed because all the elements appears in the composition cell are also in D4. And since composition of transformation is associative, so associative property is also found. Also, from the first row, this is R0, R90, R180, R270, H, V, D, D dash, and similarly these are the same as the left column, and these are the same as the top row. So we say that R0 and R0, this is the identity element of the group, and we search for the identity element in each row and each column. Then here is identity, 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 this is also identity, this is also identity. And from the identity element, we say that R180 and R180 gives R0. So the inverse of R180 is also R180. Similarly, H and H gives R0. That is, the inverse of H is also H. V and V gives R0. That is, the inverse of V is V. Similarly, D gives R0. Similarly, D gives R0. So, all the element of this set is its own inverse. Okay, so we call it a group because it holds closure, it satisfies associative, R0 with the identity, and each element have unique inverse. So it is a group and it is called Dihedral Group D4. And order of the group is 8. Similarly, if we take an equilateral triangle, then we get D3. Order of the group is 6. And if we take n-gon, regular n-gon, then order of the group Dn, this is 2n. Here we see an important property that this is the principal diagonal, this is the principal diagonal, okay, but with respect to the principal diagonal, this D dash V H, but here is D dash D H V. So this and this are not same. Similarly, any other element or any other row and column, this is same. No, this is also change. R270, R270, R0, but here D dash, here D. So this is not symmetric. And since this is not symmetric about the principal diagonal, so we say that this is a non-abelian group. So it is clear that dihedral group is a non-abelian group and it contains 2n elements. If the regular polygon contains n element. Okay, thank you for watching, and this is the today's class.